Okay, so the session's being recorded again. Just everybody be mindful of your participation, whether you're chatting. I will allow the audio in a second, but just remember everything's being recorded, so please conduct yourself in a professional and respectful manner. Okay, so here we go. Let me share my application. So there's... So in this example, I think that's the question, Wei. So here's the example. So when we did these scenarios, we did get to a point here, right here, where so if you look between lot 3 and 4, you'll see the slope 3.37. So generally, everything is at least minimum 2%, maximum 3%, except for here. And the scenario you're looking at here is when you're forcing the front drainer. So if you go back to your spreadsheet, let me show you on the spreadsheet. Actually, I think it's here on the spreadsheet. So that when you're in this scenario, and this is the exception, when you're in this scenario where you're between these two, so from the front all the way to the back, 2%, that's the lowest front drainer with a full usable backyard, or the next one down is a split. So when you're between these two scenarios, okay, let me zoom in here a little bit more. Right, when you're between here, so this is a front drainer, 2%, and this is a split drainer, minus 2%. So when you're between these two numbers, the solution is to come up from the backyard to the back of the house at 2%, and then the result, the slope from the front of the lot to the back of the house is going to be a little bit steeper than 3. Okay, and if that's the case, then you end up with that scenario that I just drew here between 3 and 4. That's the only time you're allowed to be a little bit steeper than 3. And whatever that is, I'll accept it. Okay, you'll see it might creep up to 3, even 4%. That's fine. Okay, if your solution is to come up from the back at 2%, you're going to have to accept the fact that this is going to be steeper than 3. But it shouldn't be ridiculous. It shouldn't be anywhere near 5. Okay, but it'll be close. Okay, does that answer your question? So there's only one scenario. Okay, so let's look at my drawing. Sorry, when I try to list the lot lines near the cul-de-sac, the whole boundary gets selected on the edge. Okay, so then what you do is this. It's just lines on top of each other. Yeah, 2.5 is fine. So let's go back to here. Let me share my screen. Okay, so when that happens, when you're trying to select, this happens on the edge. So when you're trying to select the lot line under here, right, there's a lot line under there. All you have to do is turn off this boundary layer. Okay? And if it's not there, then you have to measure the distance from the end to the end. So just use DI for distance and go end point to end point. And that'll give you the length, in my case, 36,123. Okay, so if there's no lot line on the end, if there's no lot line here, then you may have to just measure the length yourself. Okay, Warren, does that answer your question? Okay. So again, just a little bit of review. You can see here, and there was a typo, and you might want to change this. This layer where the existing ground is at the back, it should be called existing, not proposed. That was a mistake I made in assignment 3. So you should have a layer. You should have a layer at the front for all the front lot corners, proposed. You should have a layer at the back for existing elevation, and then you should have a layer for all of the lot grading that you're going to do. And then you should also have a layer in the center. This layer here for the center line should be on a separate layer as well. Okay. All of the proposed points are in the same groups though. If you look at my groups, they're all the same. So if you go to my point groups, I have an FG group layer. So this and this layer are all in the same group. This layer at the back, the existing ground, is in the existing layer, and then the layers in the center, these layers here, I'll show you the actual description is CL, they all go into this other layer. And they get included based on the fact that they're CL. Now, the interesting thing is this layer, CL, if you look at the properties, points, elevation, and if you're in this group, FG, points, elevation. They're exactly the same. I said temp because I didn't want you to read the elevations. So if I change that one, they should be exactly the same. So they look the same even though they're in different groups. Right? So the look of these proposed points, the look of these proposed points, the look of these proposed points are the same. This is a different layer. This is one layer. This is another layer. This is a third layer. And then the existing at the back is a fourth layer. Yes, Stephen. So there's three things at play. We have layers. So I have one layer, two layer, three layer, four layers. There's four layers. There's only two groups though, or sorry, three groups, existing and proposed, and the proposed has two. There's a center line. I want to separate my proposed center line from my other proposed layers. So let me see if I can fix that. Let's clean it up for you. Okay, so these center line points, they should be on a different layer. So let me just talk about each one separately so that it's obvious. So this should be on the layer called C Road Center Proposed. Okay, so let's do this again. Okay, so let me start this discussion again. Again, this is just housekeeping, okay? There's a layer at the back here, existing, right? So the perimeter, the existing ground layer is on one layer. That comes from the, yes, they are trunk. They're at the center line, each station. Okay, so these points, they're on their own layer. Okay, and it should be called existing, not proposed. So that was a typo that I had in the last assignment. I think I asked you to call these proposed. So these points go on their own layer and they go in their own group. Then we have the front lot corners. These are the ones on the street line, right? All the ones on the street line. So this is actually wrong and this is wrong, or sorry, this one's actually wrong. So we'll look at that. Right, this one here, this one's on the wrong layer. It should be here. So the front lot corners on the subdivision should all be on one layer and they should all be in the FG group. Then we have the proposed. So all the design that you do for lot grading, that's also in the same group as the front lot corners, but they're on a separate layer. And then finally, we have the center line. They're in their own group and their own layer. Okay, so I want to see those. They're going to look exactly like everything in the, so this style and this style are exactly the same. However, they're on different layers. Okay, so there are 1, 2, 3, 4 layers. There's 1, 2, and these two are in the same group, 3 groups. And this group and this group have the same style for point and marker, point, layer and marker. Okay, now at the end of the day, you're going to take this layer, and this layer. These all proposed, 3 different layers. I would make them all the same color, so you can't really tell that they're on, that you've categorized them differently. So I would take these proposed points and make them all red. The reason I have different colors is so that as I'm creating them, I know that they're going on the correct layer. At the end of the day, they could all be red. If you want to work smart, I would leave them as different colors and go into your grading plan. And if you go into the grading plan and you go into the viewport, right, I'm going to double click inside the viewport. If I go to my layer control here for those 3 layers, I can actually have the viewport layer. I can on paper make them all red. So in the viewport, they're all red. So they all look exactly the same on paper. However, in model space, I can keep them different colors so that as I'm creating them, they're going onto the correct layer. So there's a few ways of managing this. I like doing it this way. I like keeping everything on different layers with different colors while I'm doing my work. But for presentation, you shouldn't be able to tell you have 3 layers. They should all look the same. These are all proposed points. Okay, even the center line ones, they all look the same. There's 2 groups here and 3 layers, but you can't tell because they all have the same style. They all have the same layer color. right? So everything here looks like it's all finished ground. But when you get into the details of how you manage this, you've got 3 different layers and 2 different proposed groups. Because at the end of the day, you don't want to build your surface with this one. These are the points that build your surface, and they're all in the same group. Let me just add my audio. You can ask questions. You can turn your mute off. If you're not talking, please keep your mute on. Okay, any questions about that? This is just a tip on how to manage your information. Okay, so if you have any questions, you can actually unmute yourself. You should be able to unmute yourself. The next thing you want to do is when you're done all your design, and you should keep these for reference. Remember the distance from this node to this node is 0.3 above. Remember the distance here from this node to this node should be 0.3 above. You can keep this number relative to this number. You can keep the existing ground explicit so it's easy to check. So whenever I look at this number, this is going to be 0.3 higher. When I look at this number, this is going to be 0.3 higher, and so on. That's how these points are born, if you remember from the last assignment. Okay? So when you build your surface, right, and I'll do that again here. I can delete this. I'll start again. So to build your finished ground surface, you right-click on surface, create a new surface, give it a name, FG, finished ground. Say OK, it's empty. I'm going to add the point group called FG. And now it builds a surface using all the finished ground points, the front lot corners and all your proposed design. Notice it does not use the center line because they're in a different group. I do not want the center line on this surface. Okay, you'll see why when we do assignment 6. The other thing you'll see is the elevation at the back. This surface has an elevation at the back because of this point that's in the FG group. It does not use the existing ground elevations. You have to have a proposed elevation at the back. So even if these 2 numbers are the same, the surface is being built by this one. So if this is missing, it won't add this point to the surface, right? So you always have to have a proposed point at the back, even though it might have the same elevation as the existing ground. The last thing you need to do is add the boundary. The boundary really should coincide with, let me just push this to the back. This is the boundary of the site, right? This layer. So you can see here we've got some stuff outside and we've got some stuff way out here. And if I don't get rid of these triangle edges out here, outside of this limit, it's going to do an earthworks volume calc out here. So that's no good. You got to clean that up. And then finally in here, you'll see if these are missing, let me show you what I mean here, right? This curve here, let me update my point group and rebuild my surface. It's going to miss this shape. See this arc versus this line? There's a blank right here. Right? If I look at the surface, this arc is not part of the surface. Object viewer. Right? You see how the curve is missing? So you're going to get an error there as well. So there's information here that shouldn't be there. All this is garbage. Right? And even out here, there's a piece that's there that shouldn't be. And then there's a piece that's missing. So to get rid of the missing pieces, you can add this as a boundary. That's one way, right? So we could do this. We can go to boundary, add, and then click on this, and it shrink wraps it, right? So now it's nice and clean, right? There's no more triangle edges here. All this is tidied up. That's one way of doing it. Let me undo that. Okay, so now they're back. So I remove the boundary. Or you can just manually go to the edits, delete line, and just delete what shouldn't be there. Anything outside this blue boundary should be gone. So let's get rid of that. And I'm going to get rid of all of this and all of this and this. So now I'm just tidying up the edge instead of building a boundary, right? I want it to be tight and so on. Oh, here's another one. This shouldn't be there either. And I think we're good. So now there's the limit. So now I've deleted anything that shouldn't be there, right? So object viewer, so you can see the shape of the site. But what's missing is this piece. I've deleted, but now I need to add this curve. So the way to do that is I make a copy of one of these proposed points from the node, and I'm just going to manually snapping to the end of the cul-de-sac, right? Near point, near point, near point, near point, near point, near point, by eye. And all of these points all of these points, elevation from surface, are going to come from the proposed road corridor, just like any other point on the proposed road corridor. Right? So all of these points now come from the same source that any straight line point comes from. This information that I just added, if I update the group, now you'll see it builds all the way up there. It approximates the curve, and then I've got some lines that show up that shouldn't be there, so I'm going to delete those. So I'll get rid of these so that you get a nice curve definition. I'll get rid of these. And if you look at this in 3D, now you'll see that curve shows up, right? It approximates the curve by the points I put in. So that's how you get the shape there. So there's stuff to delete, stuff that shouldn't be there, and stuff that needs to be added. Now these additional points, this stuff here, these additional points, you can't delete them, but nobody wants to see them. I only added them to the mix because I wanted to improve my surface, but nobody needs to see those. So you got a couple of options here. You can't delete them, so I can put them on a layer, called def points. So this layer, def points, has a special property. If you look here, def points, it will not, see here it's faded. The print button is faded. This is always a no plot layer. So anything drafted on def points will not plot on paper. So the advantage of that is you can always see them in the drawing, but never in paper. So you'll see how they kind of show up here. But when I go to print, that layer is a no plot layer, so they will not show up. Right? So they're not there. So you need that in the surface. You need the data in the drawing to be defined on the surface, but you don't want to see them on paper. They're only there for making sure that the surface gets built properly. The finished ground surface itself, right? You can kind of start to see it in 3D. You know, in my case, I have a lot of walkouts. You can see here, right? The kind of hard to see. You can see here's the high point, right? So there's the front of the house. There's the back of the house. This is the 3-to-1 slope in the house. Then there's your usable backyard. And then there's a little more 3-to-1 going down to the back of the lot. As a matter of fact, if you look at, I'll show you here, remember that I have a wall going around. If I turn on my existing ground surface, and if I look at both surfaces at the same time, Object Viewer, you can see that's vertically exaggerated. So let me fix that. Object Viewer. I actually want to change these. No, standard is correct. 10 view, standard, make them both the same. Okay, so the style here and here, Object Viewer. Oh, no, maybe it is wrong. Okay, I'll have to check that. But you'll be able to see how one compares to the other, I think. Let me just make sure the style is correct. Standard. Okay, I'll have to check that. Anyway, you can look at both at the same time. They should be close to each other. I don't know why mine are off like that. I wonder if I translated one. Anyway, don't worry about that. Okay, so then you can see, you can check your surface, just like in assignment 1, you can check it for spikes. That looks pretty good. And that's your finished ground surface. So you have to build this finished ground surface as part of assignment 4. Okay? As a matter of fact, I'm going to be checking the surface. And the surface, when I look at your surface, I'll be able to tell if something's off. Like, let's say this number is wrong. Suppose this is the case. Object Viewer, update. Okay. At a glance, everything looks good. If I look at your surface in 3D, Object Viewer, oh, there's a big spike on the surface. What's the problem there? So then you got to go in and fix that. So when you look at the surface in 3D, it kind of shows you whether everything makes sense or not. So it's easier to tell whether your design is correct, generally speaking, when you look at the surface. You can't get lost in the numbers. If you look at the elevations to see if they're correct, then you're gonna get too far down a path where you get lost in the numbers, right? You need to look at this in a general sense. Okay, so that's just some tips and tricks about this. You can't build the surface until all your lot grading is done. And you have to, I know it's very, very meticulous, you have to design each lot line one at a time, right? So you have to look at the difference between the front and the existing back, decide what to do. Look at the difference between front and back, decide what to do. Look at the difference between front and back, decide what to do, and so on. Well, then you'll have to see what it is. Is it a front lot corner that's a spike, or is it one of your design points? Okay. If this is wrong, then you have to check your surface from the corridor. If one of these is wrong, then you may have to redo the lot grading. A common mistake for this design stuff is if you meant to type in 3%, but you put in 3 to 1. So then it ends up steeper rather than flatter. So sometimes instead of G, you use S. If you've been lot grading, you know exactly what that means. If you type G for percent grade or S versus slope, something to 1, if you mix those up, sometimes you end up with these spikes. But at a glance, when you look at the surface, as a matter of fact, if you look at the style for the surface, you can actually add to the style. If you enhance the style, so let me go to, I'm going to create a new style. Here's one that I like to use just for checking. Yeah, you don't have to do this, but this is one I like to do. So I make a copy of the standard one. All right, and I'll call this one check. Whoops, check. And then I'll look at the contours. I'm going to put a lot of contours. So every 0.1, so it's going to be a lot of contours. And I'm going to vertically exaggerate this 5 times. And then I have to do the same to the triangles. Vertically exaggerate 5 times. And then I'm going to go to my display, and I want to see all my contours, and I want to see them in red. And then when I look at this in 3D, in the model view, I want that to be red as well. So when I turn it in 3D, it has the same look, right? So in the plan view, it looks like this. In the 3D view, it's got the same look. And now I'm going to apply that to my FG surface. Check. All right, so there's my surface. So at a glance, you can see, where the contours are close together, you know those are 3 to 1s. Where the contours are further apart, you know those are the 3 and 2%. Here I've got that spike. See all these contours, how many there are? This is the problem right here. This number is wrong. Okay, so I'm going to get that from the corridor surface again. Corridor surface, roads, and now it's correct. It looks better. Object viewer, and here's what my surface looks like in 3D. Vertically exaggerated. I've stretched it 5 times in the vertical. Okay, so you can see on the road, the contours are flat across. That doesn't make sense right now, but that's what I want. And then you can see the high point at the front of the house, 3%, 3 to 1, usable backyard, 3 to 1. Okay, and there's the design for this. Over here, there's some front drainers. Right here, there's some front drainers, and so on. So I use this surface to check. And again, you can just read the contours in the plan view to check, right? The 3 to 1 slopes, are they in the right spot? Right, here's the front of the house, here's the back of the house. The toe of slope is at the back of the house. The top of slope is somewhere between the front and back. I have 3 to 1 at the back, and so on. There's my usable backyard. There's my front yard. There's my front and back of building. So, when you look at this in 3D, it really tells you whether everything makes sense or not. Now, is it perfect? It's hard to tell, but at a glance, everything looks like it's doing the right thing. And how do I know I have walkouts? How do I know I have walkouts? See, at the end near the cul-de-sac, I'm getting bigger and bigger walkouts, right? Full walkouts with 3 to 1 at the back. That almost appears when you look at your profile. The existing ground versus the proposed ground is huge. There's a big difference. So I would expect at this end to have mostly walkouts with possibly some 3 to 1 or retaining walls at the back, right? Over here, they're compatible. Right? It's actually the existing ground at center is higher than the proposed. So maybe I have some front drainers. And in fact, that's exactly what's happening here. I have some front drainers. Right here, I have some front drainers. Now, the profile tells you the relationship between existing and proposed at the center line. But from the center line to the back of the lot might not be a big difference. So this relationship at center is also happening at the back of the lots on both sides. Is that necessarily going to be true all the time? No, but certainly it looks that way in this case. So this is a typical relationship between proposed and existing, like almost throughout the whole site. And if you want to look at that, I'm going to draw a polyline across here. And I'm going to draw a quick profile. You don't have to do this. Again, this is just for visualization. If I draw what's called a quick profile, it'll create a temporary alignment from this. I can look at everything at the same time. My proposed, I want it to look like the proposed road. My existing, I want it to look like an existing road. And my road surface, that's also proposed for style. I'm going to say left to right road. So this is a temporary profile. I'm going to put it here. Oops. I should see. Okay, let's get rid of existing. For some reason, it's way down there, but here it is. Here's the proposed corridor, but my finished ground is modeled straight across from street line to street line. And if I look carefully, you'll see my proposed corridor is a little bit wider than the street line point right here, right? Because I made my corridor a little bit wider. So that's how I got that elevation at the front. So there's my proposed, and then you can see the cross section, right? Front of the lot, front of the house, back of the house, usable backyard, 3-to-1 down to existing, or the top of wall. So there may be, if existing ground's down here, I might have a wall here. Okay, same thing on the other side. And this is dynamic. If you want to use this tool, again, you don't have to do this, but if I move this around, if I move this polyline, don't delete it, right? But if I move this polyline to the crescent or the cul-de-sac, this thing adjusts. If I make it longer, it'll adjust. So it's just a temporary view. And there it is. You can see it's much wider through here now because that's the cul-de-sac. But I still have a walkout with some 3-to-1 at the back. So that's a dynamic view. Again, I could put it anywhere and it'll update the cross section. Okay, but it's temporary. As soon as I delete this, this disappears. There you go. Okay, so just some tips and tricks on creating this surface. So for this assignment, if you go back to the assignment requirements, you must create this surface, the FG surface, and just keep it as a no display, but you have to build it correctly. Create the finished ground, name it FG using the point group, and then make sure that you review the surface by viewing it in 3D, which is what I've been demonstrating just now. Okay, and then again, make it a no display. I'll change the style to review it, right? So once you have it, once you're happy with it, you can put this as a no display because nobody needs to see it. It's only there for analysis and checking. And then nobody needs to see your corridor. And then you can just show your grading plan, okay? Including the contours. You have to add your existing ground contours and labels. Oops. With the appropriate style. And labels and so on. Okay, so that's all spelled out here as well. So this is a little bit of review. Whoops. If you go to the assignment again. Sorry, desktop. So you have to create a existing ground. Where is it? Yeah, show the existing ground. And then it tells you the interval, every quarter meter major, minor, every 1 meter major. The color should be 8 for both. The label color should be 7, which is white, and then you have to have a style for the label. Okay, so you have to show all that. And that's basically assignment number 4. Now, I know it's a lot of work. There's a lot to do. There's a high volume of grading design to do, but with the grading, it's a matter of making it look good. Rotate the points so that they are either parallel if you can, or perpendicular as the other option for the rotation angle. And even the rotation, I've actually rotated the points on center, right? So for every station, you should have an elevation, right? For every station, every 20 meters, you should have an elevation. As a matter of fact, what are the legends? The legend is what you see here. This is what you show in the legend. So you want to see an example of a proposed elevation, an existing elevation, an existing contour. You want to make sure you show all of these. Now, if your design has all walkouts and no front drainers or transition or split or black split, it doesn't matter. You have to show all of these. These are all the possibilities. And if you don't have any of them on your plan, so be it. But you have to show all 5 of these labels, even if you only use 2 or 3 of them. Okay, and then the maintenance hall. This really doesn't matter until later, but it'll come. It's not complete yet. We haven't designed the pipes, right? So we did show the circles, and my legend is wrong, right? This does not look like this, right? So whatever you see in the plan view should be reflected in the legend. But that's generally it. There are other items which we're not going to do in this course, like surface features, maintenance holes, catch basins, valve chambers, hydrants, anything you would see on the surface, which we're not adding, right? But that's what the legend looks like. Okay, so I've given you a PDF of this as an example. The details, what I actually want in terms of styles and so on, is in the document. So this is the standard, right? This is everything that I want, but when you look at the last drawing, this is just an example of what it's going to look like. For instance, if you look here, 59, 58, 57, this is 1 meter contour interval. I asked you for quarter meter. So do what I said. Okay? So this is just a sample. It's not the details. You have to read the assignment. Everything I need is right here. Okay, and that's basically all I wanted to cover today. So tomorrow, the rest of today and tomorrow, I want to have more of a work period. Next week, it's due on Friday, but I will begin talking about pipes. Okay, I'm going to give you the pipe design. We'll have an engineering discussion, not a Civil 3D discussion, of what the pipe design is going to be. So I will include that next week. I'm not going to bother you too much right now because I know you're concentrating on other things. So I'm going to use the rest of today's class as a work period. If anybody has any questions, if there's any corrections you need to make to the previous assignment and you're not sure how to proceed, now's a good time. And what I'll do is I'll, if you want, you can email me or a meeting request a meeting, and I'll send you a link to the Microsoft Teams link, right? If you have specific questions about your assignment, we'll have some private one-on-one meetings to do that. Okay, I don't want to do it in front of the whole class, okay, because it's going to be different for everybody. Any other questions? General questions. If you have specific questions about your assignment, email me right now, and I'll set up a meeting, and I'll deal with you one-on-one. Okay, and I'll be available for the rest of today's class till 12:30.